Hello, everyone, and welcome to the first presentation of the storage thread. We have Elaine, and he's going to be the first presenter. The session is 6A, and a few housekeeping notes before we start. So there is a session feedback. There is a link in the agenda, so please follow the link and give us your feedback. I was asked to say that to explain that the best answer to question why one is 5 rather than 9. So just keeping that in mind. The copy of the presentation will be available from the conference website, so you'll be able to download the presentation. And just without further ado, I'll pass it to Elaine. Again, if you have any questions, put them in the chat and I'll monitor it. Now it is to you, Elaine.
Good morning, everyone. I'm Adam Bourgard, and I'm the product manager for mainframe and in-system replication at Hitachi Vantara. And this morning I'm going to talk about storage, cyber resilience, and partners and ecosystem. Should you have any question, as Michael was mentioning, you please throw that in the chat or raise your hand, and I'll address your question. Thank you very much in advance for your question. I'm going to start with discussing about availability. So that's Z16 and Z17 has the same availability, which is 8/9 of availability. So it's quite low because it's a third of a second per year. So it's really excellent availability, and it's really unmatched with servers like laptops and servers for open systems. So it's really very high availability. The availability is interesting subject because the availability does depend upon the technology and the architecture. So we have some claims of availability which are depending upon the features, and there are some claims of availability that are interesting because it's availability without talking about maintenance. If you are if you need 2 hours or more for maintenance and you're losing your availability, that's not real availability. So nowadays you cannot have downtimes, and nowadays customers are looking for high availability. So you certainly need to look at architectures that allows high availability, like basic hyperswap, which increase the availability for which is a high availability feature, which allows to hyperswap if there is a problem on the primary storage to switch on the secondary storage, or on GDPS, which can increase which is a high availability architecture, which allows to get high availability. And then you need to check your hardware vendors for the availability of each storage. But basically, we have the availability which is made on the architecture, and if you are based on the cluster, you need to shut down one part of the cluster for running the maintenance on that node. So it's the availability may be depending upon the conditions. So you need to be careful about availability and what you can do, and the impact on performance and on the availability. So the maintenance can be killing the customer workload when you are doing the microcode upgrade. The architecture also can have can be interesting. So you've got different type of architecture depending upon the vendor. So you can have architecture which can be so-called NVMe. I remember a customer a few years ago asking me about our backend, and I told him that our backend was all NVMe, and some other vendor was told them that the backend was NVMe, and the last generation for IBM just introduced NVMe disk for backend. So there is the capabilities, there is the architecture, and there is a known or the marketing part of it. So you need to be careful when you're talking about the architecture and look at deep question regarding the architecture. So people see the advantage of NVMe well, when you are talking with open system storage, sysprog, for example, because NVMe does bring bandwidth. The bandwidth is much larger on the same PCIe. You running NVMe protocols, the bandwidth is much larger than the previous protocol. The latencies is also much lower. It does allow some scalability, but because you are using less the PCIe backend, and you can also have some economies in terms of sustainability, which is a high subject in Europe or in the EMEA because of the bad habit that our government had to put tax on everything, including some thought about green gas emission, but it does consume much less than the previous generation. So this is good for our planet. In terms of performance, also you need to check if your vendor does want to show you everything about the internals of the machine, so you can if you have the possibility to get SMF records, which can be used to map the internals of the storage and used to match with the what you see from ZOS. So it may be sometime interesting to see both sides of the tunnel and see if there is some contention, which is extremely rare these days when with the powerful storage we have, but can happen anyway. And with the SSD, it does also mask a lot of performance issues that we used to see when we used to have spinning disk. Replication. So basically, replication are most of the replication technology are push technology. So if you're looking at PPRC or what's called now Metro Mirror, it's a push technology. So the primary is pushing the data to the secondary, and the secondary acknowledge to the primary, and then you can acknowledge to the host. And then you've got the MTMM, which is the from one source you can have two different targets synchronous in synchronous mode, and between the two targets you've got what is called the MTIR, which is a multi-target incremental resync, which allows to resync the pairs in the case there is an hyper swap, so you can resync the pairs and quickly have a second copy of your data just in case you would lose one of the site, and the replication technology are more or less based on this paradigm, and the only one which used to have a different model in the past used to be XRC, which XRC was pulling the data from the controller, the primary controller, from a host somewhere, and writing it down to the secondary storage far away, but limited with Python extension. So with a 10,000 footprint, you can have a universal replicator, which is a pool technology, and the remote is fetching the data from the primary and allowing to fetch the data in permanently and not by batch and for asynchronous replication. So you can have a very low RPO without sacrificing the performance, because you are removing some pressure on the primary controller, because whatever you want to do, the push technology does need to have some processor usage on the primary and some controls on the primary, that the data is well received on the secondary, and the data is correctly and correct, and consistency is maintained. So you need to have several features that are involved with this process, and especially in asynchronous mode, because you need to maintain the data coherency and data consistency, whatever happens in between. And so the capability to have a pool technology and expand the size of the cache with some physical disk in order to destage the data when the bandwidth is not sufficient for the remote to fetch the data, are really key technology in order to maintain the lowest RPO as possible for the customer. In terms of compatibility, so there are features which are features which can be introduced by IBM to mask some deficiency in the architecture. So you've got some features that you can see appearing at some point and disappearing at some point, because the architecture has changed, or IBM has fixed the issue in its disk storage subsystem, and so you need to have some control or some understanding of what IBM is trying to push or trying to make by introducing some features which are not necessarily useful for depending upon the architecture of the storage. And the introduction of SSD did really change the game, and really is very fast and allows to mask a lot of deficiencies that we had in the past. In terms of compatibility, IBM has got some programs. So the programs are the basic qualification, and the basic qualification is basically a vendor pays IBM to check that the storage is compatible with IBM and does respond correctly to each and every FICON command, and especially during recoveries. And this is important for customer to be sure that your vendor does has right compatibility with IBM, and IBM will support it. So there is a program with IBM which allows cross support. So it does allow the vendors to access the feature list and the detail of the feature and the specification of the features, so they can implement the feature in time and when it's useful for the customer. Um, the the second qualification also from IBM is they've got a qualification program for GDPS, which is very important for the customer in order to be sure that if there is some disk, some Hitachi disk, for example, in customer site, the configuration will work satisfactory in a GDPS environment and will react the way it should be reacting as per IBM specifications. So Hitachi is participating to this program. So the current generation, the 5000 series, has been qualified with basic qualification, and we just have finished, and IBM should publish in the coming days the qualification letter. We have qualified the 5600 with GDPS Metro Mirror with 3DC and with 4DC. So, and we also have qualified MTMM with MTIR. So the qualification letter should be available shortly from IBM. But so if you would need some information, please you can contact your vendor, or you can contact Hitachi for specifically Hitachi disk. You certainly have been aware or made aware by your vendor about IFCS. So IFCS is two parts. There is the authentication, which means that the source, the Z server, basically the worldwide name to the Z server port, does talk to the worldwide name of the storage port and not another port. So it does allow to verify that the source port and the target port are correct and are not changed and cannot be changed, otherwise the authentication would fail. And EDIF is the encryption data in flight. So this is the outside of the Z series, the data is encrypted and it's decrypted at the storage level. Sometimes I've got some customer telling me that yeah, that's interesting, but what is interest when I'm already encrypting my data? So if the data is already encrypted, doesn't mean that the commands are encrypted. So basically what you are doing is when you are doing edif, the commands are also encrypted between the source, the server, and the storage, allowing to have more protection for you, because when you give the information regarding the commands, it means that you also are giving the information where the data reside, and it may be or can be useful information for a bad actor. So even if you're encrypting your data, you are not encrypting again the data, but the command will be encrypted on the wire. IBM has issued a statement of direction last year, in April last year, that with the any storage that is available starting January 1st of this year will need to be compatible to IFCS. Otherwise, any new generation will not be able to connect to IBM Z server. And they also did a statement of direction that the generation after the Z17, I don't know if it will be a Z18 or not, but if it's Z18, it will require IFCS to be enabled for connecting to mainframe. So no storage will be able to connect to a Z18 without this capability. So it's starting to be important to think about the implementing this feature. The key is a rotating key, so it's not always the same key. By default, I think I do recall it's every 8 hours the key is changed, and you need to have access to a key management server in order to enable this feature. In terms of security, you also can have data at rest encryption, and data at rest encryption does allow to work with different flavor, I would say. One is the data at rest encryption is done with a key which can be a key for each SSD or each disk. I don't know how do you call it, but yeah, and the key can be generated by the storage, so it can be auto-generated key. It can be backed up on a key management server, so you can have a backup of the key on this key management server, but it also can be a key that does not reside inside the storage. So you need the key. You can also have the key management server required to be connected in order to power on the storage. And you also need to have some solution for cyber security. So either you're restoring from tape, where the tape does reside on S3 storage in order object storage, in order to be sure that the copy cannot be modified or deleted by criminal operation, or the directory of these tapes cannot be modified or deleted. Or you can have a cyber resiliency solution that allows to have the copies of the data and locked, and allow this copy not being just to be immutable, so you cannot modify any of the data. You also need to be sure that your and it's mandatory, and everyone, I guess, does comply to this requirement, but it needs to be a zero trust architecture for a cyber resiliency solution, because otherwise you would need to question your solution, and modification may have critical which may have critical impact, needs to be a two-user acknowledgement. Otherwise, it can be dangerous. The cyber resiliency solution may not be a good idea to give all the keys of the house to the same team. So if you look at the cyber attacks mainframe as of today. The cyber attacks are mainly for on the mainframe are mainly, and there are some. There are not no lot of people talking about it, but there are several of them which did happen, and usually it's internal bad actor. So as we know that internal, most of the threat is internal. Maybe it's not a very good idea to give your management of your cyber resiliency solution to the same team as the team which does manage the mainframe. You can also think about solution which allows to isolate the cyber resiliency solution to a bunker rather than on the same site, because especially in the US, the primary storage on some case may be considered as a crime scene. So you are, for some entities in the US, you are not allowed to restore the data on the primary site because some FBI guys may look at at finding a signature for the virus or worm or whatever you call it. You need also to be sure that when you're setting a cyber security solution, a cyber resiliency solution, sorry, you need to be very careful that you are not stopped by some constraint on the storage, which would not allow to make an image when you need an image. So freezing the IOs for making an image may be an issue, and having a timeout on the time to freeze, it's not necessarily a good idea, because if you would have a cyber attack, you may want to take an image straight away when there is not a lot of data which has been corrupted. So you may need to check and be able to do that. In terms of cyber security, you've got several tools on the market. Hitachi is partnering with Mentegrity, with FIM Plus, because this product has allowed to detect malware, test the image that you are making, but also can detect data exfiltration. And that's the main issue on the mainframe also. A lot of analysts think that data exfiltration is one of the biggest risks on the mainframe, and they are putting the exfiltrated data on the cloud, waiting for some quantum processing power to be available to crack the database quickly, or the encryption algorithm quickly. Because if you're a bank, the banking customer are extremely unlikely to change bank unless they are having a new mortgage for housing, but most of the customer will stay with the same account. So there is a lot of data which can be interesting for bad actors in bank. In terms of eco-friendly, you need to rely on partners which are having a good practice in terms of publishing the data from green gas emission. So the in terms of efficient power supplies, for example, you'll see that some vendor does only introduce 80 plus platinum today, where this is available on the market for a long time, and this helped reducing the green gas emission, which and the sustainability. So it's important to rely on a partner which can help you to have a sustainability story and a good track about what the green gas emission are reduced year after year. The difference between the Hitachi 4DC with IBM 4DC, for example, is that with the true copy synchronous is out of the asynchronous replication, so you don't need to toggle or to change the copy type to go from asynchronous to synchronous. And we have done IBM has qualified this with GDPS, so we got a solution which can be fully integrated with GDPS and work perfectly for DC. So we are looking as some customer are asking for 6DC. So we are looking at introducing 6DC also for customer. Hitachi has introduced some feature. I'm going to be a little bit quicker on this feature because most of you certainly know this feature, but reserve transfer allows to share the disk between sysplexes. So if there is an hyper swap and the reserve was set on a volume, the reserve will be transferred, and after 2 minutes maximum, the reserve will be vanished on the old primary storage. The other ones are really self-explanatory, maybe not UCB look. UCB look is to give you the access to the microcode level from the GDPS panels, and PPA system allows to have less messages each time there is an hyperswap or if there is a change state for one pair. In terms of exploiting the internal SMF record which are given by Hitachi, we work with the Open Mainframe Foundation, and Zebra has been enhanced to be aware of the Hitachi SMF record, so you can now use Zebra in order to pull the SMF record from Hitachi and merge them with the server record and create a dashboard with Grafana, for example, in order to get correlation. So this is an Hitachi product for doing that and having a view. And here is an example of a graph that you can create yourself, or some comes with the product. So you've got already pre-canned view, but you can have here, you've got a view of the front end, a view of the processor usage, and you've got some detailed view below that we don't see here, but basically you can have every important part of the storage detailed by viewed and detailed. In terms of partnership, there are some partner we are working with for the customers. So we are integrated with several customers. But if you're looking for lowering the bill for your DB2 tool, Infotel has got neat DB2 tool, which may be resold by big names, and I'm not sure we can specify it, but they are providing several tools to large IBM vendor, let's say it like this. Mentegrity, as I mentioned, is really specialized and really have the best tool in terms of cybersecurity as of today. They can detect and stop any new encryption that is seen in your environment, and call for the your security administrator to check that this new encryption schema is normal, and if normal, you can let it go. Otherwise, he does stop the new encryption as soon as he detects it. There is some interesting ways to accelerate your DB2 and VSAM database with data kinetics, which allows to fetch the data in memory rather than fetching the data on disk, even if the disk are really fast and you've got high performance link in order to access the data. It's really consume less MSUs, and it has helped to get data faster and to increase the flow of transaction. So we're working with data kinetics in that area. SAS Pivotor IntelliMagic, which has been purchased by IBM, and Precisely are partners that knows about Hitachi record. So if you're recording the internals of an Hitachi storage, you can use this tool. And Precisely does take the SMF record and process them in order to be available for any tool like Splunk, for example. If you have Splunk at home, you can use Precisely to get all mainframe records and get them working correctly, and having single pane of glass to see every single alert. Hitachi is working with BMC, and we've got a contract with BMC, so Hitachi can resell any BMC product. So we've got in terms of tapes or virtual tapes, there is several partner. BMC and Logan Software are a solution for tapes, which allows to have a non-sticky solution for transparent cloud tiering. So they are using zip for the data mover. So this, in order to do that, they are relying on the storage class from DFSMS in order to trap the IOs, which goes to the virtual tape from BMC or from Logan Software, and move the data by a data mover which run on zip. So it has allow to get less MSU consumed, and Hitachi as BMC as in his catalog. So you've got some benefit from this tools, and interesting cost saving. This is the end of my presentation. So if you want to give a feedback, you can give a feedback. Please do so in order to see if, how we can improve the knowledge of people, the conference, and we'll hand over to Michael. Thank you very much.
Thank you very much, Elaine, and thank you everyone for joining. So as Elaine mentioned, please submit your feedback. There is the link is on the screen, and there's also a link at the agenda. If you have any more questions, you can also put them in the chat, and I'll make sure or to send them to Elaine. And that ends this session. So thank you very much, everyone, and have a good day and rest of conference. Bye bye.